All right, hello students. This is 9.5 binomial theorem, and all right, so let's go ahead and expand this. So I'm going to rewrite it as x plus y squared, x plus y, and then I'm going to go ahead and expand this first part. So that gives us x squared plus 2x plus y squared, and then that's going to be multiplied by x plus y. Okay. Then I'm going to use the FOIL method, but you could use the FOIL or box method. Okay, so once you do that, you're going to get x to the third plus, oops, it should have a y there, 2x squared y plus xy squared plus x squared y plus 2xy squared plus y to the third. Now I could rearrange these for it to have a certain pattern, but instead I'm just going to go ahead and show you with the binomial theorem. So the binomial theorem will help us expand things that have, instead of 3 there, you could have like 5 or 7, and you don't want to FOIL it out, right? So I'm going to go ahead and write this as a(n) to the 0, b to the 0. Basically, you decrease a, the exponent, and you increase b, and you keep on doing that until you reach b to the n. So the previous one would be a to the 1, and then b to the n minus 1, and a to the 0 there technically. All right, next we're going to learn about n choose r, which we call binomial coefficients. And in the next section, you are going to see that we're going to call this combinations, but for now, again, we're going to just call this binomial coefficients. So we could rewrite binomial coefficients as n choose r with the parentheses, okay, and then the formula is going to be n factorial over r factorial and then n minus r factorial on the bottom. All right, so we're going to go ahead and evaluate the following without a calculator. So you could actually use a calculator, but I'm going to show you how to do it without a calculator. So let's go ahead and apply this. So this is our n and this is our r. Plug it into the formula. So we have 5 factorial on the top, and then 3 factorial on the bottom, and then 5 minus 3, which is 2 factorial on the bottom too. So we could rewrite that as 5 times 4 times 3 times 2 times 1. And then the bottom we could write it as 3 times 2 times 1. And then 2 factorial is 2 times 1. So now we could just go ahead and try to cancel out as many things as we can. There's a 3 on top and the bottom. Then another 2. And then this 4 divided by that 2 is 2 on the top. So what we have left is 5 times 2 on the top and then nothing on the bottom. Okay, so let's go ahead and try the next one. 10 factorial over 7 factorial and then 10 minus 7 factorial, which is 3. Okay, so we could expand this. 10 times 9 times 8 times 7. Now going back to our previous sections, remember I left that factorial at the end. I'm going to do that again because notice I have 7 factorial on the bottom. And then here this is 3 factorial, so it's going to be 3 times 2 times 1. Okay, now we're going to cancel out what we can. Cancel out these 7 factorials. 9 divided by 3 is 3. 8 divided by 2 is 4. And then we're going to go ahead and multiply those out. So we get 120. Okay, next thing we're going to do is we're going to go ahead and expand this next one. All right, so we have 20 factorial over 18 factorial, and then 20 minus 18, which is 2 factorial. So 20 times 19 times 18 factorial. all over 18 factorial, and then 2 times 1. So you could cancel out the 18s, and then the 20 divided by, this is multiplication, the 20 divided by the 2, that's 10. So 10 times 19, that 1 doesn't really count, is 190. All right, so for the next one, we have Pascal's triangle. So I'm going to go ahead and write Pascal's triangle for you. You're going to start off with 3 ones. And then you're going to go ahead and add 1 plus 1 gives you 2. You put 1s on the edges. And then you basically do the same thing. 1 plus 2 is 3. And then you put 1s around the edges. 1 plus 3 is 4. 3 plus 3 is 6. 4, and then 1 around the edges. 5, 10, 10, 5, 1 around the edges. Okay, then we have 6, 15, 20, 15, 6, and then 1 around the edges. I'm going to go to 7 because my example uses 7. Okay, and then I just want to show you how this relates to binomials coefficients. So if I were to relate this back to the binomials, you want to start off with 1, 1. Then for the next one, you're going to go 1, 0, 1, 1. Then you're going to go 2, 1, 2, 2, and then, 2, 1. And then 2, 2. Then for the next one, you're going to go 3, 0, 3, 1, 3, 2, and 3, 3. So imagine if I asked you to find the coefficients of the 100th term. You don't want to create a Pascal's triangle all the way up to the 100th term. Instead, what you could do is you could start off with 100, 0, 100, 1, and maybe I would only ask you for the first 4 terms instead of the whole entire, the 100 terms. Okay, so let's go ahead and each row of Pascal's triangle corresponds to the binomial coefficient to the nth term. So let's go ahead and expand this out. We're going to go ahead and use the coefficients. So these are the coefficients, and you're going to start off with 1. You're going to start off with x, which is your a, and raise that to the 7th power. And then y technically is raised to the 0 power. And then you're just going to decrease the x and increase the y, and then make sure to put those coefficients in front. So 7 is the next coefficient, x to the 6, y to the 1, plus 21, x to the 5th, y squared, plus 35, x to the 4th, y third, plus 35, another 35, x to the 3rd, y to the 4th, plus 21, x squared, y to the 3rd. I'm going to add over here because I ran out of space, 7, x, y to the 4th, plus, oops, I made a mistake. See, you want to be very careful because here I started decreasing, and I tend to do that, and I always like to double check. So 4, 5, 6, and then 1 y to the 7th. So again, just like I said, I would just double check that I'm increasing and then decreasing. Alright, so the first thing you're going to do is you're going to write out the Pascal's triangle, and you want to make sure that you go all the way to the number on there, so that would be the 5th row in this case. So that would be this one. And what I'm going to do is I'm going to go ahead and do it a little bit different. I'm going to basically space out my numbers. So 1 plus 5 plus 10 plus 10 plus 5 and then plus 1. Okay, and then I'm going to go ahead and fill it in. Now, so you're going to take x squared and raise it to the 5th power. And then you're going to take 1 and raise it to the 0 power. So that's just 1. Okay, then I'm going to take the next one, x squared. Now raise it to the 4th power. And then 1 becomes 1 squared, which is still 1. So at this point, I'm going to ignore the 1. Okay, so then I have x squared raised to the 3rd power. X squared raised to the 2nd power. And then x squared raised to the 1st power, and then the 1 is just there at the very end. So we have x to the 10 plus 5x to the 8th plus 10x to the 6th plus 10x to the 4th plus 5x squared plus 1 at the very end. And so this is our answer right here.